2.2, a central relationship. Here is a circle with central angle QAC. So talking about this angle right here. 1. Use a protractor to find the approximate degree measure of angle QAC. So let's try that. Oh, I was wondering why is it look blurry. There we go. That looks better. Okay. Okay. So to use a protractor, just a quick review. You put the vertex where the hole is, and then you align your two lines on the protractor and the angle you're trying to measure. All right, and as you can see, I'm running into a bit of a predicament here because, it's going to be a bit of an estimate where that angle is. So what I can do instead is I can extend this ray here so that I can get a more accurate reading of this angle. Let me try to show that. See how that's a little bit off? Especially since we're using a tool like a protractor, and the fact that I'm extending the line, I really want to make sure I'm as accurate as possible. All right, great. So if I'm looking, I see that the protractor goes through 80 and 100. So if I'm looking at this diagram, how many degrees should this be, 80 or 100? Well, it's an acute angle, so if I'm going to choose between 80 and 100, 80 degrees would be the acute measure of the two. So the measure of angle QAC is equal to 80 degrees. 2. Mark a point B on the circle that is not on the highlighted arc C to Q. Each member of your group should choose a different location for point B. Draw chords BC and BQ. Use a protractor to find the approximate degree measure of an angle QBC. So basically what they're saying is I'm going to put a point B anywhere that's not on this blue arc. So it could be here to here, anywhere on there. So I'm going to choose a few of them, since this is really an activity you would do as a group. Unfortunately, I'm just here on my own, although Miss Garcia is virtually with me, you could say. Okay, so the first thing I'm going to do is I'm going to put a point B like all the way up here. So for this one, this inscribed angle, as you'll see when you connect the dots, you form an inscribed angle. You'll notice that the angle does not include the center of the circle. So that's going to be one example. Okay, so let's measure this angle. Let's see how many degrees it is. And again, I'm going to want to extend this so that I really get an accurate reading. And this will probably be pretty inaccurate relatively because, like you can see here, it's not perfectly, the lines don't perfectly meet here. There's a lot of human error going on. But I'll try and make it as accurate as possible. All right, that looks pretty good. And we can see here that I hit a nice round number, 40 or 140, and that's clearly an acute angle, so I'm going to choose 40 for that one. All right, so I'm noticing, okay, maybe there's some sort of relationship here. The next example I'm going to choose, I'm going to call that B sub 1, B1. I'm going to choose another one, and this one is going to have an inscribed angle that like surrounds the center A. So I'm going to put B2 right here, and we'll make it so that if you look at this, it's like surrounding, the center is within the angle. Because I want to try and get as much variant, different ways of doing it. And maybe I should have done that in a different color just to really, and I think I will do that. I'll just trace over it in purple, so that you can really see the different inscribed angles here. All right, good. It pops a little bit more. Okay, so for this one, again, I'm going to extend my line to really get a nice reading for this angle measure. And we can see that. Again, I'm going through 40 and 140, so I will choose 40 because this is clearly an acute angle. So getting 40 twice, that's probably a good indication this will always happen. But let's do it one more time. We say in math, if you can find a pattern 3 times, that usually indicates that it's true. Not always, you like to prove that it works all the time, but 3 examples is usually you can be pretty confident. Let's use another color, let's use green. All All right, and this time I'm going to draw an inscribed angle where one of the chords goes through the center, exactly. So I've gone an inscribed angle that doesn't include the center, that surrounds the center, and one that goes through the center. So those are 3 different examples that you can possibly have. All right, for this one, I already actually drew a line that went through here, so I've sort of done that work already for myself. All right, let's see. And again, we're going to see that it goes through 40 and 140. So really what you should get here is every single time you're going to get that the measure of angle CBQ is going to be equal to 40 degrees. Okay. Or I guess they called it QBC, CBQ, same thing, just forwards and backwards. Does not matter. All right, share your results with my group. What do you notice about your answers? Well, they're all the same, right? But we're trying to make some sort of assumption about the central angle and an inscribed angle. What do the central angle and inscribed angle have in common? Well, they both subtend the same arc, CQ. They both intersect that arc, exactly. So I noticed that, well, 40 is 1/2 of 80, or I can double 40 to get 80. So what I'm going to say is, if an arc, if a central angle, I'll start off, if a central angle, and inscribed angle subtend, or again, if that word is too foreign to you, you can say intersect, the same arc, the inscribed angle will have a measure that is what of the central angle's measure. Right? If my inscribed angle was 80, if my inscribed angle was 40 and my central angle is 80, then we can say the inscribed angle is half of the central angle's measure. So in a much nicer, not nicer, but I always like to have diagrams to sort of express these things. Let's see if I can do it down here where I have more space. And there's my very, very faint circle. So what we're really saying here is that if that's my center, right? If I know that the measure of this central angle is theta, and I have an inscribed angle that is subtending that same arc, we know that the measure of this is going to be theta over 2. All right, now we're actually going to prove that algebraically or geometrically. So are you ready for more? Here's a special case of an inscribed angle where one of the chords that defines the inscribed angle, again, that defines the inscribed angle, goes through the center. So this chord ED is going through the center C. That's what they're saying here. Like I said, there are 3 cases, right? You can have an angle that, an inscribed angle that surrounds the center, that, I'll actually sketch it quickly. That surrounds the center, that does not include the center, and then here's the third case where one of the chords actually hits the center on the nose. All right. So, the central angle DCF measures theta degrees, and the inscribed angle DEF measures alpha degrees. Prove that alpha equals 1/2 of theta. So we stated this really in our definition, but we sort of measured it, right? Who knows? Maybe I was wrong. Maybe it was 39 degrees and 80, which wouldn't be exactly equal to half. So it's always better to prove things with variables because that means it works no matter what the measure is. Okay, so the first thing I'm going to do, I see a triangle, right? That means I'm going to mark up what I know about this triangle. And if this is the center, and these are line segments connecting the center to the circumference, we know those are radii. Well, what are true about all radii in a circle? They're all congruent. So right off the bat, I know this is not just any triangle. This is an isosceles triangle. So if I look at angle F and angle C, can I say anything about those two angles? Well, not quite anything about angle ECF quite yet. But angle EFC is opposite from this side marked with one hash mark. So is angle FEC. Alpha is across, is opposite from the one hash mark. By the isosceles triangle theorem, these two angles must be congruent. They must both be alpha. Right? If this was 60 degrees, this would have to be 60. It's an isosceles triangle where two of the angles are congruent, two of the sides are congruent. So I know those two. I don't know this angle yet. However, this is a straight line. Therefore, it must be 180 degrees. If this angle is theta, what must the measure for this angle be? Well, like you would do in your calculator, if this was 60, you would simply do 100 minus 60 to get the measure of this angle. 180 minus 60 to get the measure of this angle. So in this case, I'll do 180 minus theta. So now I have all three angles within this triangle. So I can use my triangle sum theory, angle sum theory, to state that alpha plus 180 minus theta must be equal to how many degrees are in a triangle? 180. All right, now I'm going to move some stuff around. I notice that alpha and theta are on opposite sides, so I'm going to want to do that. I also notice I have 180 and 180 here, right? So I can just quickly cancel those out. So alpha plus alpha is just the same as 2 alpha. And be careful when you write that. Those look like 2s, so yeah, but you know, that looks like an alpha, like a fish, sort of. All right, so minus theta is equal to 0. Now I want to get theta to the other side, so I'm going to add theta to both sides here. Now I get 2 times alpha is equal to theta, because 0 plus anything is just whatever you added to 0. Now in this equation, alpha is all alone. So right now I have 2 times alpha. So how do I get alpha alone? I divide both sides by 2. And maybe it would have been better for me to draw my 2's like that so they don't look like an alpha. So these are going to cancel out. And I'm left with alpha equals theta over 2. Well, it's not quite what they wanted me to have, but it's actually equivalent, right? I can also write alpha equals 1/2 times theta. Those are equivalent expressions, right? Because if I were to multiply these two, it would really just be theta over 1. Then you'd have 1 times theta is theta, 2 times 1 is 2. So those are really equivalent fractions, equivalent expressions. All right. So if you want to get some extra credit for this marking period, if you could do a proof showing that no matter how you draw the inscribed angle, right, if it surrounds the center, if it doesn't even include the center, if you're always going to get that measure of this inscribed angle being 1/2 of the central angle that subtend the same arc, that would definitely be a great way to get extra credit. All right, that's it.